Hello everyone, and welcome back to PreAlgebra with Miss Betsy. We're continuing our work with fractions, and today we're just going to be adding and subtracting when we have like denominators, which is a very straightforward approach that we're going to take. And of course I've got a lame joke for you. See which one I'd like to use right now. Can you tell me what nation it is that is tough on rats? Extermination. I told you it was lame. I warned you that one. Let's see what we would do if we have these two rectangles and we have them divided into fourths plus a rectangle here that is also divided into fourths, and we are pretending, as always, that I know how to write things evenly. This here, I have two of those fourths are shaded in the one rectangle. One of those rectangles is shaded in to the other one. If I would pick this piece up and set it in, or just count them, I have 1, 2, 3 fourths of a rectangle. Because these are the same size, they would overlap. Could pick this piece right here, fit it right in here, just take it out, plop it right in. And I would have 3/4 because these are theoretically the same size. Obviously not the same size the way I've drawn them, but you're working with me here and we're saying that these are equal sized rectangles divided into an equal number of even spaces, which is 4 spaces. 2 spaces in the one rectangle, 1 space in the other rectangle, which we could actually pick up and fill in to give us a total of 3 of those 4 rectangular spaces filled, or 3/4. And all that we did here when we were comparing, or when we were combining here, we had 2/4 plus 1/4, and we saw that that sum is equal to 3/4. What did we do? If we had two fractions with the same denominator, we added the numerators together and we kept the denominator. This is the algebraic way that we would use to describe what we've done here. Now of course we have to put the little caveat in here that says C can't be equal to 0, because if C were equal to 0, then we would be dividing by 0, which of course we know we can't do. So, same thing would happen also if we were subtracting. If we had 2/4 and we took away 1/4, we would have 1/4 left, correct? So we have the same thing. If you have two rational numbers with the same denominator and you are subtracting them, all you need to do is keep that same denominator and subtract the numerators. And of course C can't be equal to 0, they are equal, because you're still dealing with a fraction and you cannot divide any number by 0. Adding numerators, adding like fractions with like denominators, add the numerators. Subtracting fractions with like denominators, subtract the numerators. Very straightforward. 4/9 plus 2/9. 4/9 plus 2/9. Now if I were in my class at co-op, I'd pick this up and pitch it across the room, so I just, here, finally hit the ground. 4/9 plus 2/9. These are like fractions because they have the same denominator. How are we going to do this? We're going to add the numerators, keep the denominator. 4 plus 2 is 6/9. What do you notice here? You notice here that this is not reduced to lowest terms. How do we reduce a fraction to lowest terms? Divide by the greatest common factor to reduce to lowest terms. I put a video out there all by itself that is just referring specifically to dividing by GCF to reduce a fraction to lowest terms. And once it's uploaded, I'm going to pin that to the top of your video links on your ARC website for those of you who are working with me through a co-op. How do we find the greatest common factor? We prime factor each number. 6 is 2 times 3. 9 is 3 times 3. The greatest common factor. How did I get this prime factorization? The numbers are small enough I can just tell you 2 times 3 and 3 times 3. You use your factor trees so that the only factors are prime numbers. The greatest common factor is those factors that appear in common. We now see that the greatest common factor of 6 and 9 is a 3, and we are going to divide the numerator and the denominator by the GCF to arrive at the final reduced form of our fraction, which is 2/3. When you add fractions together with like denominators, add the numerators. If the fraction then that results when you add the two together is not reduced to lowest terms, figure out what your greatest common factor is, divide the numerator and the denominator by that greatest common factor. That will always give you your reduced to lowest terms fraction. Let's go ahead and pick another one. 11/12 minus 3/12. (11/12 minus 3/12). Because we have the same denominator here, which is a 12, all we have to do is subtract the numerators, and I just gave you the answer instead of writing 11 minus 3. 11 minus 3 is 8/12. And you immediately recognize that that fraction is not reduced to lowest terms because they're both even numbers. Now you might be able to instantly know that this is going to reduce to 2/3 because you can divide both the numerator and the denominator by 4. But let me go through the steps to show you greatest common factor. You want to prime factor 8. 8, 2 times 4, this is one way to do it. So we can say that 8 can be written as a prime, and a product of primes by saying 2 cubed. 2 times 2 times 2. We also can prime factor 12. 4 times 3, this is one way to do it. And we can say that 12 is 2 squared times 3. I've used the exponential form to indicate 2 times 2 times 2 for the prime factorization of 8, and 2 times 2 to indicate that we have 2 factors of 2 in our prime factorization of 12 here. What do we do to find our GCF? To find our GCF, we take whatever prime factor we can find in common with both our numerator and our denominator, the smallest exponent that's used, and lo and behold, for our greatest common factor, we have 2 squared, which of course is equal to 4. So our GCF is equal to 4. Now we divide the numerator by 4 and the denominator by 4 to end up with not 4/3, but 8 divided by 4 is 2. To end up with the 2/3, which is the reduced form that I told you about at the beginning of a problem. That's all that's involved in reducing, in adding and subtracting fractions with like denominators. Now let's go ahead and show you what they want you to do here. I've told my kids before, as long as you have an improper fraction reduced to lowest terms, I'm all right with it. But for a while your book might ask you to give mixed numbers. So here we have add or subtract. Let's go ahead and do 8/9 plus 5/9. 8/9 plus 5/9. Denominators are the same. Add the numerators. 8 plus 5 over 9. That's 13/9. 13 is prime, so this is actually an improper fraction reduced to lowest terms. But let's take an improper fraction reduced to lowest terms down to a mixed number. Improper fraction, it has been reduced to lowest terms. That's what we have over here. We're going to convert to a mixed number. How do you convert an improper fraction to a mixed number? To a mixed number, you work out the long division problem. 13 divided by 9. 1 times 9 is 9. When you subtract, you have a remainder of 4, which you do not write like I just did. You have a remainder of 4. The remainder becomes the numerator. The denominator is the number by which you are dividing. So your answer that they are looking for is 1 4/9. The mixed number 1 4/9. For this chapter that we're working on, they're asking you to take an improper fraction, even if it has already been reduced to lowest terms, and rename it as a mixed number. That's all that's involved in this section. I'll see you next time.